Welcome everyone to a new episode of our Vlog series. My name is Benjamin. I'm a PhD candidate here at the Center for Law and Economics at ETH Zurich. It is well known that ideological leaders attempt to control intellectual activity through suppression. But what are the consequences of this suppression for development? This is the topic of today's paper that we're going to talk about, and I'm very excited to get started. I'm very happy to have with me today Roberto Galbiati, research professor at CNRS-Sciences Po and a research fellow of the Center for Economic Policy Research.
Thank you so much for having me. I'm very happy to be here.
Today we're going to talk about your paper, Science Under Acquisition. Maybe as a start, before going into the discussion, could you give us a little bit of an overview of the paper?
Sure. The paper starts with a very simple question. So when you have strong ideological leaders that try in a way or another to control the production of thoughts and ideas, this control that can take many forms, from incarceration of people that are opposing to the regime, to censorship, to taxation of some kind of ideas, we know, and at least we have the intuition, that this has some impact on the production of ideas. But how long this lasts? What are the long-term consequences of this? And what are the channels that are activated in the economy by this kind of actions is still very much unknown. And this is exactly the question that we ask in this paper. In particular, we focus on a specific case, that is the Italian Inquisition in the 16th century and on, where heretical ideas were targeted by the Catholic Church, and by targeting heretical ideas, the Catholic Church was indirectly targeting the scientific production. So our question is, what has been the impact of this targeting of ideas on the production of scientists in Italy over a couple of centuries, and what are the channels that have been activated to observe the effects that we do. And so why this is important? So it's important because we learn something about the production of science, but it's very much important because we know that the production of scientific ideas is the engine of economic growth.
Now, you already mentioned these mechanisms, which I think are a very fascinating part of this paper. You establish or identify three kinds of different effects. Could you tell us a little bit more about what they are and how they interact with each other?
Of course. So the idea of the paper is pretty simple. Imagine that you have a shock that increases the cost of scientific production. If you think to nowadays, you can think about a government that cuts salaries or cuts funding for scientists. In the past, in our case, it was the Roman Inquisition that through tribunals all around Italy could go after ideas that were not respectful of the Catholic orthodoxy. Think about the prominent case of Galileo. So our idea is very simple. So if you are someone that is talented and at his young or her young age have to decide what you will do in your life, and you have the choice between becoming a scientist or becoming something else, you will think about what the consequences of your career choice. And these consequences of the career choice depend on the lifetime earnings of your career choice and how difficult it is to develop a certain career and where you can develop this career. So using this intuition, we then define what are the key elements of your lifetime earnings and your lifetime, let's say, well-being. So they depend on how easy it is to make your job, and the intuition is that if you are doing science in a place where there is some inquisition, it will be harder, so you have a sort of cost. This is what we call deterrence. That if you train yourself as a scientist in a place where the Catholic orthodoxy through the Inquisition is very strong, you will have to pay some cost in terms of stigma. Imagine that you do some kind of science that people, or some kind of research that people don't like around you, and you are stubborn and you keep on doing that, but the social pressure and you put some stigma. And the third one is that your capacity of doing science or any kind of job depends on the human capital that you have accumulated. And the human capital that you have accumulated depends on how many masters you have around you that can teach you. This is true today. So yeah, we are at ETH, we have fantastic professors that teach you something, and the capacity of students of building the human capital depends on the interaction with a teacher. But it was even more true in the past, where you didn't have big university centers. There were some that were rare, so the presence of masters around you matter much more. So the idea here is that when the Inquisition kicks in, through the deterrence effect, so the cost of doing science, there are scientists that decide to move. And these scientists that decide to move in places that are not under the grip of Inquisition, instead of teaching to potential scientists in Italy, go to teach to potential scientists elsewhere. So this machine triggers a sort of snowball effect, for which, because of deterrence, people moved out of Italy, and the future generation were attracted either to study abroad, or when decided to stay in Italy, didn't have enough master to study science with. And so they diverted and moved to other kind of professions. So with these simple ideas, with these three ingredients, we are able to reproduce and hence to explain the observed pattern of divergence in the number of scientists that we observe in Italy and in the rest of Europe through the 16th century. Until the 1540s, more or less, the number of scientists in Italy and the rest of Europe is sort of perfectly overlapping. And they follow the same trend. Starting from the 50s on, so when the Inquisition kicks in, the two trends start to diverge. The rest of Europe keeps on growing and goes a little bit more, and Italy starts stagnating. Okay, this is a puzzle. The puzzle has been there in history for a long time, and our little contribution has to explain this. Of course, this is not the final answer to the story. There are many other elements that can explain this divergence, but it's, we believe, an important ingredient.
You use this dynamic structural model instead of, for instance, a difference in differences approach. Could you tell us a little bit more about why you choose to do so?
Well, this interesting question. It's a bit technical, but intuitively you have two ways that, in my view, are complement in doing empirical research in economics and social sciences. One is to be very much, let's say, agnostic about the theoretical mechanism that underline a certain effect, and to let the data speak through a technique that approaches some like an experimental idea. That's what I do usually most of my research, but in this particular case, doing this was problematic exactly because what I just said before. Because because notable people moved a lot in the past. So when we look into the data, we have that about the 40% of the notable people in the past were moving from city to city and from state to state. So when people move, and if you think to a treatment control group, your control group is contaminated, quote, quote, by people that are treated. So it's like, polluting your control treatment. That's why, your control group. That's exactly why reduced form strategy, like for instance a diff in diff, is not ideal in this setting. So you go to the second way of doing this kind of research, that is basically building a theory and then adapting and then studying how data fit to your theory. And this is exactly what we do in this case. It may appear more constrained, of course, because you are sort of constraining your data to a given structure. But as far as your theory is plausible and is well defined, and your model is well specified, it's able to deliver some very interesting explanation that you couldn't get otherwise. On the top of that, this kind of approach is pretty helpful when you want to quantify the mechanism relative to the relative effect of the mechanism with respect to other mechanisms. This allows us to take into account all different possible explanations in the same context and to identify the relative effect pretty neatly.
Thank you. This already brings us to our last question. Given that becoming a scientist and producing science becomes more costly, both in terms of funding and in terms of more control by authoritarian regimes, what do you think we can take away from your paper today?
Well, just to be precise, scientists for the moment are not suppressed, luckily so. But there is a lot of suppression of funding in science around the globe in many places. And so I think that naively, as Europeans, we may think that this is good for us in a way, in the sense, well, we will be able to call back talents and science in Europe will benefit. But overall, I think that when it's more difficult to produce science, the whole globe, the whole humanity is going to lose something. And so there is a way to partially compensate this is to massively fund science in places where doing science is still possible and is free. But this is not an easy political option, because you have to convince people that funding science is worth taxes and is worth public spending, and so it's not an easy task.
Thank you very much, Roberto.
Thank you for having me. It was a lot of fun to talk with you, and thanks a lot for the invitation in Zurich.
And to you, thank you very much for joining today, and looking forward to see you in the next one.